Okay, so yesterday GCF, today LCM. What is the LCM? The LCM is the smallest. The L is least common multiple, smallest number that is a multiple of the given numbers. Smallest number that is a multiple of the given numbers. So for an example on this one, I'm going to use the number 8 and the number 12. Remember now, a multiple. Let's take the number 8. What are multiples of 8? 8, 16, 24, 32, 40, 48, 56, etc. What are multiples of 12? 12, 24, 36, 48, etc., etc., etc. Is 96 a multiple of 8? 96, multiple of 8. Yes, it is. 8 times 12 is 96. Is 96 a multiple of 12? Yes, right? What? 8 times 12 is 96. So 96, yes. So now is 96 the least common multiple? And the answer is no. What is the least common multiple? Nia? 48. Nope, there's one smaller than that. Luke? 8 is not a multiple of 12. All right, Christina? 4 is not a multiple of either one. Ashley? 24 is the LCM. It is the lowest common multiple. 3 times 8 is 24, so 24 is a multiple of 8. 2 times 12 is 24, so 24 is a multiple of 12. What we want to do is we want to come up with a mathematical method, right, of figuring that out, because that gets tricky. So there are tons of multiples of these two numbers. We need to find the smallest number that's a multiple of both the numbers. And if there's 3, then it'd be the smallest of the 3. So there's a method, and therefore then it'll make life easier on you if you understand the methodology. All right, we start out just like a GCF. Factor the numbers to prime numbers. Same way, right? That's what we did with the GCF. We're going to do it with the LCM. Factor the number to prime numbers. Number 2 is make a. Oh, come on. Make a. There you go. Make a shot. Make a shot. All right, so that's the same. Hey, hint and clue number 1, line up the factors. That's the same. Number 2, only put the same factors in the same column. That's the same. Have we done anything different so far? No. The only difference is how you read the answer. That's the difference between a GCF and an LCM. The only difference is how you read the solution. If it was a GCF, I made this statement. This is a great short answer question on a quiz or test. Now, this is LCM. Think back to yesterday. The GCF is the blank of the factors. Anybody remember when that blank, Allison? Intersection. Exactly right. So therefore, class, the LCM will be the not intersection. What goes with intersection? What's the other operation of sets besides intersection? Say it if you know it. All right. Woo. A lot of interesting answers. No, union. Union. You tell me you guys never had union in 6th grade? Really? Union? I know those of you that were in Math 7 had union. I know that. An intersection. Oh, yes. Guaranteed or no money back. All right. So quiet, please. Quiet, please. So let me then take a moment and explain to you the concept of union. Don't write this, just watch and think, okay? I want to get this concept down so you understand what's going on. If I had a set with the numbers 2, 3, 7, and 9 in it, don't write this, just watch. And I had a set with it 2, 3. Let's go 5, and I'll leave it at that. If I were to union the sets, it means to have all of the first set and all of the second set, and we don't need to repeat. So if I were to union these, it would be the number 2, the number 3, the number 5, the number 7, and the number 9. The 2 and the 3, they both have. The second one has a 5, so we're going to include the 5. Top one has a 7, so we're going to include 7, and top one has a 9. Now, if we were doing that's union, right? Symbols like that. If we were doing intersection like yesterday, they would intersect at 2 and 3, right? 2 and 3 would be the intersection, but 2, 3, 5, 7, 9 would be the union, putting together. So it's a different operation. It's a different concept. You've been to a wedding. Dearly beloved, we are gathered this day to join this man and woman in holy matrimony, right? It's a union. You're putting together is what you're doing. So you'll get more aspects of union and intersection later on in your math career. Edward?
You put 9 as one of the factors.
I didn't say they were prime numbers. Okay, those were sets. Sets is any collection of objects. Could be anything in there. Could be cars. Could be, twiddlywinks, whatever they are. Could be marbles. Could be shoes. Slices of pizza. Now we're getting there. All right, so anyhow, how do you say the union or the LCM? Well, it's pretty easy. As long as you did what you're supposed to do, you made a chart, and you lined up your factors, and you only put the same factors in the same column, the LCM is every column with any number in it gets represented. I need a 2 for this first 2 column. I need another 2 for this second 2 column. I need a 2 for this third 2 column because the first one had a 2. I need a 3 for the 3 column. And I need a 5 for the 5 column because the second one had a 5. I'm doing union, putting them together. All right, so pay attention to this. With GCFs, the numbers are usually small, and we multiply them out and leave our answer as a final numbered answer. Because we're not using our calculators yet, and we won't until we're done with fractions, I don't want you to waste the time of multiplying these out, because it's just a time. You should already know how to multiply. So we're trying to learn a concept of the LCM. I don't want to take extra time. I don't want your homework to take you extra long because now you got to do all this multiplication on the side. Got it? Same thing with the quiz or test. I don't want to have you take that extra time. So we're going to leave our answer in factored exponent form. We already know how to do that from factoring the prime numbers, right? So our final answer will be 2 cubed times 3 times 5. Class, let me ask you this question. Do we put them in order? Yes. All right, we put them in order when we were factoring. We put them in order now. Math is consistent. We do what we do, and we are consistent in our math. Okay, so that's union. Every column gets represented, whether there's one number in it or 2. And it's not, look, this is a mistake I see students make. Look at the first column here. This is not a 2 times 2. It's a 2 for the 2 column. Okay? So don't make that mistake. Let's do some examples and see if we can get the procedure down. All right. So here we got number 3A. We got our 30 and 24. First thing I'm going to do is factor, right? So a 30, 3 times 10. And a 10, 2 times 5. Somebody factor 24 for me. Julia, go ahead. Okay. Okay. All right, sounds good. And we have both factored both of them to prime numbers. And you know what? I'm going to do the 24 first because of the 3 2s it has. So we know we got 3 2s. and then it has a 3. Now I'm going to come back and do the top one. And remember, line up. That 2 goes in the row with that first 2. The 3 goes in the 3 column. And now I need a 5 column. Right? Makes sense like what we did yesterday with GCF's question, Christina? The 30 was a 2, a 3, and a 5, and the 24, 2, 2, 2, 3. Okay, so somebody raise your hand and tell me what to put down at the bottom. Colby? Correct. So it's going to be 2 times 2 times 2 times 3 times 5 to complete our chart. And then Colby jumped ahead right to the final answer. 2 cubed times 3 times 5. Right? Do you agree? Brendan, question? Is it kind of like normal? Well, it's remember, you're factoring the 30, you're factoring the 24, and now you have to figure out what is the smallest number that's a multiple of both the 30 and the 24. And really, this number is what? 8 times 5 is 40. 40 times 3 is 120. So we really found 120 is the number we're after. But we're not going to take the time to multiply it out because it takes extra time. And again, we're trying to learn the concept. But really, the 120 is what we're after. By the way, and we'll get to this in the back, just so you know where we're going, the LCM is the LCD if they're denominators. What's an LCD? You should know that. Somebody raise your hand and tell me what an LCD is. Chloe? Least common denominator. What's the importance of a least common denominator? What does common denominator allow you to do? Raph? Not reduce. Ashley? Add fractions. That's where this is heading. And interesting fractions. See, our LCM is going to allow us to find the LCD of fractions. And that's an important aspect. Okay, that's where we're heading. Let's do the bottom one. 22 and 28. Why don't you guys do that? I'm going to pause the video. All right, on 3, give me your answer. 1, 2, 3. 2 squared times 7 times 11. Beautiful, right? Pretty easy. 2 squared times 7 times 11. Hey, the biggest trick with LCMs and GCFs, don't get them confused. That's the biggest deal. You got to keep it straight. All right, let's go to our second page there in your notes. Okay, so when you look at C, do you spaz out? What do you say when somebody raise your hand? What do you say when you look at C? Kristen? Okay. I'm really trying to get an idea of what in the world do you do? Aaron? Yeah, it's already factored, right? This one's half done for you. All right, go ahead and figure out the LCM for C. Numbers are already factored for you. We're going to find the smallest number that's a multiple of both of those numbers. And it's a pretty big number. I don't even know what it is. It's ginormous. So hopefully everybody got it. I got to write my final answer. 2 cubed times 3 squared times 5 times 7. By the way, notice what I did. First off, I skipped a space for my 7. And then when I started doing the blue one, I noticed I needed a space for the 5 column. So I just crossed it out and moved it over. Not a big deal. But remember, when you write your final answer, you want it in order and you want it in exponent form, right? How many got that right? Right, pretty easy if you know what you're doing. Let's look at the next example, all right? Oh no, 3 numbers. We'll have no idea what to do now. I know this is impossible, but give it a shot. See if you can figure it out. All right, so hopefully everybody ended up with 2 times 3 squared times 5 squared times 7 squared. Okay. That was a little tricky putting it in the chart, I know. Again, normally on your paper, you're not going to be restricted to the squares like that. You're going to line them up yourself. What I do with big numbers is I just do them, spread them real far out so I can squeeze stuff in between and keep my columns. And you'll see that here in our last 2. Any questions so far, anybody? LCM's pretty simplistic if you follow the method, right? And of course, you got to remember the method. Well, let's get down to the nitty of the gritty. Again, what is the purpose of this is really to be able to find the common denominator. We also use the LCD later on. Now, we've done some equations already, right? But we haven't done equations with a bunch of fractions. And the way to solve an equation with a bunch of fractions is to get rid of the fractions. You know how you get rid of the fractions? You multiply both sides of the equation by the LCD. So LCD allows you to add fractions. It also allows you to get rid of fractions when you have an equation with a bunch of fractions. A couple of scenarios. Also later on, down the road, and again, what we're teaching now for is what you need down the road. Back toward the end of Algebra 1, next year, end of the year, it'll be, I don't know, March or so, April, we'll start dealing with polynomials. And we'll have to add them. And the denominators won't just be numbers, they'll be numbers and variables. And not only that, there's a thing called, well, we know what factoring is, but there's a way to factor a polynomial that we'll learn. And if we understand this concept of LCM now, we'll be able to do it with those complex problems later. I'll show you a glimpse of that at the end of today. All right, so anyhow, hey, the LCM is of the denominators is the LCD, right? So all we're worried about are the bottom numbers. You want to find the LCM of the denominators, so the LCD. So somebody raise your hand. What would you be factoring? What numbers are you factoring? Brendan? Correct. That's all you're worried about is factoring the 10, the 6, and the 15 and find the LCM of those three numbers. That will be the LCD. All right? Go ahead and try that. I'm going to pause. 30. Right. So in this one, the LCD is a 2 times 3 times 5, which can easily be multiplied out to a 30. Now, I picked easy numbers. I don't want you to do this in your notes. I just want you to watch for a moment, okay? Just watch now. I picked easy numbers. Thank you. All right, so I picked easy numbers because I want to show you the value of the LCM, which again is the LCD, if you do it of the denominators. All right, our common denominator is 30. Now, I did pick easy numbers, and these are numbers you could have figured out in your head that the common denominator was 30. But I want to show you the value of the LCD. So what I need you guys to do is, I need you guys to look right here. The first number came from the 10 denominator. The second number came from the 6 denominator. And the third number came from the 15 denominator, right? Now, I want you to go back. I want you to notice, looking at the 10, what is the 10 missing of the LCD? Say it if you know it. Isn't the 10 missing the 3? If I were doing this, and again, don't do this, watch. If I were doing this problem, I would want to multiply that first fraction by 3 over 3. Again, I'm going to do the denominator by 3 to get a 30, and whatever I do at the bottom, do the same thing at the top. If you look at the second number, the 6, back over here at the square, what is the 6 missing of the LCD? Say it if you know it. Isn't the 6 missing the 5, right? And so what I would do is on the bottom of that one, I would multiply by 5. Whatever I do at the bottom, I do the same thing at the top. Now let's look at the third number, the 15. What is the 15 missing of the LCD? I'm missing the 2, so I would want to multiply that one by a 2 on the bottom. Whatever I do in the bottom, I do the same thing on the top. So let me show you where we're at. 3 times 3 is 9. 10 times 3 is 30. 1 times 5 is 5. 6 times 5 is 30. 7 times 2 is 14. 15 times 2 is 30. Am I now ready to add these fractions? Hopefully you remember, how do you add fractions? Add the numerators and put it over the common denominator, right? 9 and 5 is 14. 14 and 14 is 28. I have 28 over 30. I would finish this by reducing, right? We'll talk all about this later on. We'll go into all the details, make sure that you guys are good with fractions. But this is where we're leading with the LCDs. Now, again, I chose easy numbers, 10 and 6 and 15. And by the way, there are lots of common denominators, right? Is 60 a common denominator? Can you make each of the bottoms a 60? Yes. 6 times 10, 10 times 6, and 4 times 15. You could. Is 120 a common denominator? Yes. There are a lot of common denominators, but you know what? The best one to use is the lowest common denominator, which comes from the least common multiple. And that's why this is valuable. So later on, when we're doing fractions, some of you guys, if you don't clearly see the lowest common denominator, sometimes you'll see it. You can figure, you know it because it's simple numbers. Okay, great. But if it's numbers not so easy to figure out, I'll see some of that on the side as you try to figure out the lowest common denominator so you can then do that fractional problem. All right, let's look at this last concept. Oh no, letters, it's impossible. There's no way you're going to figure out the LCD of those two fractions. But give it a shot. I know it's impossible, but see what you can do. I'm pausing the video. How many think you've got it? All right, more confident than you were yesterday. That's good. All right, well, let's see. You have 2 squared times 5 times x squared times y, right? Makes sense? The 4x is a 2 times 2 times x. The 10x squared y is a 2 times 5 times x times y. Made my chart, right? Lined up my factors. I need a 2 for the 2 column, another 2 for the 2 column, a 5 for the 5 column, an x for the x column, another x for the x column, and a y for the y column. And again, technically, this is what it is, right? 20x squared y, but we're leaving them in factored form. Kristen, question? Did you write 20x squared y? Okay, so how many had a correct answer? I'm just curious. All right, way more. Good, you guys learned way more than that. Look, that's big time algebra. All right, don't do this in your notes. Again, I want you to watch. Let's really add these fractions. Add those fractions. You got to be kidding me, Mr. Scarfy. Add those? Look at those variables. Impossible. There's no way, Jose. All right, well, let's see. Somebody tell me what to multiply the bottom of the left one by. What would I be multiplying the bottom of the left one by? Hannah, go for it. No, all I'm asking for is what to multiply the bottom of this fraction by. Remember, I'm working to get a common denominator. That's what I'm after. Chloe? Say again? Nope. 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 You got to do what I did a moment ago on this one. Right? You got to do what I did a moment ago on this one. Allison? More than that. Nathan? More than that. Colby? A little more than that. Aaron? I need to multiply the bottom by a 5xy. Again, don't do this in your notes. Watch. We'll do fractions later. And by the way, whatever you do to the bottom, you always got to do the same to the top, right? Now look, how did Colby know 5xy? What's the 4x missing? 5. What else is it missing? One of the x's. What else is it missing? No, it wasn't Colby, was it? Who was it? Aaron, sorry. All right, Colby, you got the credit, man. All right. How about the second one then? What are you going to multiply the second one by? This one's a lot easier. On 3, give me your answer. 1, 2, 3. The only thing it's missing is a 2. It's only missing this 2 right there. It's all it's missing. See, I'm going to make it match the LCD. Whatever I do the bottom, do the same thing at the top. Now watch. Just watch. 11, a negative 11 times 5 xy is a negative 55 xy. Bottom. 4 times 5 is 20, right? X times x is x squared times y. Notice how I have the LCD right now, don't I? Of course, that's what I was after. Let's do the second fraction. 9 times 2 is 18. Bottom. 10 times 2 is 20 times x squared y. Look at that. Same denominator. Isn't that amazing? How do you add fractions? Add their numerators. By the way, can we add a negative 55xy and an 18? You should already know the answer to this. Yes or no? Yes or no? Can you add them? Can somebody say why you can't add them, Kristen? So as long as the 18 had some variables, we could add them? Hayden? They're not like terms, right? They don't have the same variables, and the variables don't have the same exponents. Okay, so that's going to stay. And how do you add fractions? You add the numerators and put them over the common denominator. So if you guys had to add that, look at that. A little complicated, but you know what? That's what the answer would be. We would have done it because we know how to do LCMs. All right, I'll quit there. You got your homework.